Alright, just continuing from the last video because it cut off. We are up to question D now. So, a large weather balloon is being inflated and launched into the upper atmosphere so its cargo of a telescope can observe distant stars and planets, whatever. In the first 2 hours of its journey, the height of the balloon can be modeled by this equation, where h of t is measured in kilometers above ground level and t is measured in minutes. Find the time at which the balloon reaches its maximum height using calculus methods. Alright, the first thing we're going to do is derive this equation. So, it's going to become h dash of t. The 4.69 goes away, so, and then t squared, remember how we do fractions, that'll just be 2t over 420. Just keep in mind that this is a negative, plus 11 over 21. Alright, now when we're dealing with these questions, usually what we're going to do, actually we can simplify this further first. We can divide 420 by 2 to cancel out that 2, so h dash of t over 210, because 420 divided by 2 equals that, plus 11 over 21. Alright, now what we do with these questions is we usually like making things equal to 0 so we can solve for t. So what we're going to do is make it equal to 0. 0 equals negative 2 over 10 plus 11 over 21. Now we're going to move this to the other side, and now it becomes a positive because it was a negative before. So t over 210 equals 11 over 21. Now to solve for the time, we just have to move this 210 over here. So t will equal 210 times 11 divided by 21. So t will equal 110 minutes. Okay. So this is a merit question. It's pretty easy actually. You will be awarded merit if you have the correct time, and you have to make sure you have the right unit. So here they told us the unit is minutes. So you have to make sure you have that in your final answer. So if you get 110 minutes, you will be awarded with a merit. Achieved is differentiated to find gradient. So achieved is literally, I don't even think you have to make it equal to 0. Probably do. So this is probably achieved. Alright. Next question. Once reaching maximum altitude, the same balloon volume varies due to the sun's effective heating and cooling of gases in the balloon throughout the day, whatever. The volume, blah blah blah, can be modeled by this equation. So it looks like we've got a cubic equation. Let's just keep that in mind, where this represents the volume of the balloon in thousands of cubic meters. So let's also highlight that because it's important. And t represents the time in hours. Use calculus methods to determine the size of the maximum volume of the balloon. So it's a two-part question. We've got to first find the maximum volume of the balloon, and then the percentage of the full volume when it's at its smallest, or basically when it's the minimum, in easier words. The minimum. Okay. So let's start with finding the step 1 is find maximum volume. Right. So, as usual, first thing we're going to do is derive it. So, v dash of t equals 3t squared minus 17 times 2, that's 34t, plus 64, and that 462 goes away. And then what we do, make it equal to 0. So 3 t squared, and you'll notice that this is a quadratic equation. Plus 64 equals 0. Once we do that, we can put it in our graphics calculator or use the quadratic formula or whatever to get two values of t, which will be t equals 2.38 or t equals 8.95. 8.95. Okay. Now, going back to our knowledge of cubics. Remember, I like to draw a little diagram. So, it's a positive cubic, which means the maximum coordinate must be this one here. And the minimum coordinate must be this one here. Because the minimum x value is always higher than the maximum x value. So, to get the maximum volume, I think all we have to do is just plug it in this original equation here. So, we're going to get when V is equal to 2.38 equals 2.38 cubed minus 17, 2.38 squared, or 2.38 plus, what was that at the end? 462. 462. So, equal when the time is 2.38, that will equal 531,000 point. We're just going to round it to, I don't know, 50. You can just round it to 50. We could round it to 507, 6, whatever. Okay, so that's the maximum volume. Now we have to give it some context, so we've got to write something like maximum volume of balloon is 531,506 cubic meters. Okay, you have to put it in the context. So this is the maximum, right? We're not done yet. We've answered part 1 of the question. Now we need to calculate its percentage of the full volume when it is at its smallest. So we're going to have to find the minimum volume now. So all we have to do is minimum volume. It just equals, so when V is equal to 8.95, we're just going to plug it in the equation. That will equal 8.95 cubed minus 17, 8.95 squared plus 64, 8.95 plus 462. Okay, that's just putting it back into this equation. So when you do that, you should get when the time is equal to 8.95, not 8, sorry, 5. That should equal something like 381,000.975. And this is the minimum. Okay, this is when it's the minimum volume. Okay. So, to get the percentage, to calculate percentage, all you do is the minimum volume over the maximum volume times 100. So if we put in the values, 389.975 divided by 531.506 times 100. That should give you something like 73.4%. Okay. Now, grades wise, this is a double excellence question, right? So this is like worth big marks. To get E8, the full marks, you need to have found the maximum volume. So you needed to have found this part here, this bit, and you needed to have found the correct percentage. So those two is E8. Okay, to get E7 or 1 excellence mark, all you had to do was find the maximum volume. So this would be E7, this part here. Okay, and that's question 1 done. I will do question 2 in another video. Cheers.